Today in this video lecture, we are going to solve the Khan University Examination Board Class 10 Preliminary Examination May June 2021 Physics Paper 1. So let's come to our first question of this year. So here we have our first questions. A simple pendulum has fixed frequency and fixed amplitude, fixed frequency and variable amplitude. So actually in these options we have to identify about the frequency and amplitude of a simple pendulum. So we know that time period of the simple pendulum is 2 pi square root L over G. So the frequency of that simple pendulum would become 1 over 2 pi square root G over L. So if the length of the pendulum is same, so the frequency of that pendulum will remain constant or fixed, while amplitude of the pendulum may change. For example, this is the mean position of our pendulum, and if we displace the pendulum to this point, so this is known as the amplitude. If that pendulum starts oscillating, the amplitude of that pendulum decreases with time. So it has a fixed frequency and has variable amplitude. So option B is the right answer. Then we have question number 2. The total energy in a damp oscillation will be. So in this question, total energy, what happens to the total energy when a body is oscillating with a damp oscillation? So if we talk about the just energy of that vibrating body, so we know that the energy of the vibrating body decreases in a damp oscillation. But according to the law of conservation of energy, the total energy always remains constant. So the correct answer is option D, that the total energy of a damp oscillator is always same. Let's see question number 3. A point P marked on the rope before the rope is set to oscillate at a particular direction. And from this diagram, as we can see, that we have a transverse type of wave and we have the direction of wave given. So if the direction of wave is this, so we know that the particle will oscillate along the direction C and D, perpendicular to the direction of wave. But in this question, it asked that what is the direction of energy. So we know that wave is a carrier of energy and energy is moving in the direction of wave. So the direction of wave in this diagram is the option A. So the correct answer is option A, that the wave is moving, energy is moving in the rightward direction as the direction of wave. Then we have question number 4. What is the name given to the effect that allow the wave front to reach at point X shown in the diagram? So as we can see, the straight wave fronts or the waves are moving towards these two slits in which we have a small narrow gap. We have studied a phenomena in which whenever a waves pass through these slits with a narrow gap, the wave splits or wave spread passing through that slit or narrow gap. This splitting or spreading of wave is known as diffraction. So option C is the right answer. Let's come to our question number 5. In question number 5, we have a diagram that shows the bending of water waves from deep region of the wave, deep region of water to the shallow region of the water. So whenever wave travels from deep to shallow, there are some changes. The first one is the change in direction, that is towards normal. And the other changes that occurs in this phenomena are the speed and wavelength. These both characteristics of the wave decreases while frequency of the water waves remains same. So the wave speed decreases is the right answer. Then we have question number 6, which a child throws a stone in a still pond. When the stone hits, the wave travel outward in a circular pattern. In a very characteristic move for the child, he noticed that six waves arrives in time 3.2. We have to find the frequency of the wave. So we have six waves and we have a time 3.2 seconds. We know that frequency is the number of waves over time. Number of waves are 6 and the time is 3.2. So 6 will be divided by 3.2. Our result would be 1.875. So the correct answer for this question would be option C. Bat detects the obstacle in the path by receiving the reflected ultrasonic waves. So bats use these type of waves for their communication, for catching their prey. So the option D is the right answer. Let's move to our next question, that is question number 8. A student uses oscilloscope to compare two sounds that are sound X and Y. Both scopes are have the same scales, and these are the two diagrams of the two sound waves. So from these two diagrams, as we can see that in sound X, we have less number of waves, and in sound Y, we have more number of waves. Greater the number of waves, greater will be the pitch or frequency. Pitch is directly proportional to frequency, and frequency means number of waves. So sound Y has the large number of waves, it means it will have large frequency and large pitch. What about the volume? Volume depends on the volume is the loudness of sound. So loudness of sound is depends on the amplitude of the wave. So as we can see in this diagram, the amplitude of both wave is same. This means that the pitch of sound Y is higher, while X and Y have the same amplitude or same loudness. So option D is the right answer. Then we have question number 9. We have to identify the incident, refracted, and emergent ray. So this is the incident ray, this is refracted, and this is emergent ray. A, B, B, C, and C, D. Option A is the right answer. Let's come to our question number 10. So in question number 10, we have four diagrams. Which diagram correctly shows the formation of a real image on the screen? So, as we can see in this option, the rays are not meeting at screen. This is the meeting point. It means image is not formed on the screen. This is the incorrect answer. Similarly, from in option A and B, we can see the parallel incident ray is passing through two times focus. And the rule says that whenever the incident ray is parallel, it must pass through the principal focus. But in these two cases, the refracted ray is passing through two times focus. It's mean these options are incorrect. So the correct answer is option D, in which a parallel incident ray passing through the lens bends and pass through the focus, and the refracted rays are meeting at a point on the screen. So this is the right answer. Let's move to our next question, that is question number 11. We have a diagram of a simple microscope or simple microscope or a simple magnifying glass in which object is placed in front of the focus, and we have formed an virtual image that can be seen at a uh, point y. So the image is real, inverted is incorrect, this real is incorrect. So the correct answer is that this image is virtual image, and this image can be seen at point y. So the correct answer is option A. Let's see our next question. We have question number 12. Light enters the flat water surface at an angle of 27. So this is angle I, and we have a refractive index N. We have to find the angle of refraction R. So by using the second law of refraction, we know that N equals to sine I over sine of R. N is 1.33 and sine I is 27 divided by sine R. So for finding the value of sine R, 1.33 will be divided on the other side of the equation, sine 27 divided by 1.33. So sine of 27 will be divided by 1.33. We would get 0.3413. So value of sine 27 is divided by 1.33. So for finding the value of r in from this relation, r would be equals to sine inverse of 0.3413. So by taking the sine inverse of this, we will get 19.9 degrees. So option B will be the right answer. In the next question, we have to identify the angle of incidence and angle of refraction. This is the normal line, this is I and this is R. So angle between IN and RN are the angle of incidence and refraction, that are angle 1 and angle 4. So option B is the right answer. Then we have question number 14. The diagram shows an object position close to the thin converging lens inside the focal length. Three rays are shown and leaving the object and passing through the lens. We have to identify that the location, size, and nature of that image. So as we can see, these three refracted rays, we have three refracted rays, one, two, and three. These refracted rays are moving away from each other, it means they are diverging. So the nature of image would be virtual. So these two options will be incorrect. Similarly, it will form enlarged image, and the position of the image would be behind the object. So the correct option is option C, that the image will be formed at the right of that object, at the left of the object, and it will be virtual and enlarged image. So let's come to our next question, that is question number 15. The diagram shows a ray of light. Total internal reflection is shown between the substance A and B. So, as we know that the conditions for the total internal reflection are such that the incidence should be greater than critical, while the light must enter from rare medium to dense medium. So, in this case, light is total internally reflected. This means that this medium should be dense and this medium should be rare. And the angle here should be I greater than critical angle. So angle of incidence should be greater than critical angle, and substance A has a greater refractive index than B. So option A is the right answer in this question. Then we have question number 16. The diagram shows light passing from air into the glass, and the angle of incidence and refraction are angle P and angle S. This is incident ray and this is refracted ray. So, according to the second law of refraction, sine I to the sine R is constant or refractive index. So, here sine P over sine S would be the right answer, that is equal to the refractive index. Let's come to question number 17. In question number 17, we have a negatively charged balloon hanged near a balloon X and then near a balloon Y. This negatively charged balloon repels the balloon X and attracts the balloon Y. This shows that this balloon X is negatively charged while this balloon Y is positively charged, or it can be neutral. So the correct option in this question is balloon X is negative while balloon Y is positive. So option B is the right answer. Let's see our next question, that is question number 18. We have two similar balloons hung by side by insulating thread. They both are rubbed with the same dry clothes and becomes charged, which diagram shows how balloon hang after charging. So in this question, they are it is stated that they are rubbed with the same type of dry cloth. This means that both balloons should get the same nature of charge. So the correct answer is option B. Then let's see question number 19. A negatively charged rod is held close to one side of the metal sphere. The other side of the sphere is earthed. Which diagram shows the distribution of charge on the metal sphere? So we have three things. One is the negatively charged rod, one is the metal sphere, and the third is ground. So one thing just noted that whenever at any point ground or earth is connected, the charge cannot stay at that point. The ground point always neutralizes that ends where the ground is connected. So here, as we can see, ground is connected, but there is still negative charge there. Similarly, here the ground is connected and positive charge stays on that. So the correct option is option D, that this negatively charged rod repels all the negative charge to the other side, and the ground connected to it will move all the negative charge to the ground. So option D is the right answer. Let's see question number 20. This diagram shows two plates, positive and negatively charged plates of a capacitor, and we have to identify the correct direction or the pattern of the electric field among those parallel plates. So the correct diagram that is in option B, that they are in a straight line from positive plate towards the negative plate. Then let's see question number 21. In this question, we have through two capacitors that are connected in parallel plate capacitor in a series combination, and we have to find the how much charge will be deposited in these two capacitors. So for series combination, the total capacitance will be equals to 1 over C1 plus 1 over C2. So after solving, we will get 1 over 3 plus 1 over 3 will become 2 over 3. So C will be equals to 3 over 2, or C will be equals to 1.5 10 raised to the power minus 6 farad. So this is the total capacitance of these two capacitors. So we have to find the total charge, that is equals to Q equals CV. C is 1.5 10 raised to the power minus 6 and voltage is 50. So our correct answer would be 75 10 raised to the power minus 6 coulombs. In scientific form, it would become 7.5 10 raised to the power minus 5. So option A is the right answer. Then we have question number 2, in which we have a comb that is positively charged. And this comb is run in hairs. Let's say these are hairs. So these are hairs. It's mean this comb is positive. So these hairs will become negatively charged. So how this hairs have become negative charge? So the negative charge has flown or transferred from comb to the hair. So the correct answer is option C, that the comb loses electron to the hair that makes comb positive and the hairs negative. In question number 23, we have to identify the false statement about the electric field lines. So they never intersect each other. They start from positive and terminate into the negative. They have a particular direction from positive to negative. So the option C is the right answer, that they try to follow the longest path. Then we have question number 24. We have two bodies P and Q having masses m1 and m2, charges q1 and q2, and a distance r. We have to find the electrostatic force or Coulomb force. So electrostatic force or Coulomb force equals G m1. Sorry, electrostatic force is equals to constant K q1 q2 over r square, where K is known as the Coulomb's constant. So correct answer is F equals K Q1 Q2 over R square. Option D is our right answer. Let's see question number 25. We are in this question, we have to identify the symbol of fuse. So the correct answer is option C. This is the circuit symbol that is used to represent the fuse in the circuit diagrams. Quickly, let's see question number 26. Two resistors that are connected in parallel, and we have to find the effective resistance. So the formula for resistance in the series parallel combination is 1 over R1 plus 1 over R2. By solving 1 over 12 plus 1 over 8, so the LCM will become 24, 2 plus 3. It will become 24 over 3, that is equal to R. So 24 divided by 3 is equal to 8. So 24 divided by 5 will be equals to 4.8. So the correct answer is option C. Then see question number 27. Two resistors that are connected in parallel combination. One is of 10 ohms and the other is 5 ohms. And we have an ammeter that is connected at this point, and the reading, we have to find a reading on the ammeter. So as we can see, this is the junction and current is divided into these two parts, I1 and I2, and current in this ammeter is equals to I1 plus I2. We know that resistance is inversely proportional to the current. It's mean higher the resistance, less amount of current will pass through it. So as we can see, the first resistance is 10 ohms and the second is 5 ohms. So the greater amount of current will pass through this resistance R2. So if resistance is half, so the current passing through it will be doubled. If 2 ampere of current is passing through the resistance R1, so double of that resistance, that is 4 ampere, will pass through this resistance R2. So the total amount of current that is passing through this ammeter is 2 ampere plus 4 ampere, that is equals to 6 ampere. So the correct answer is option D. Let's see our next question. A 10 ohms and 3 ohm resistors are connected in series as shown. What would be the reading on the voltmeter? So we know that the current passing through the circuit is same. So I1 will be equals to I2. So the I amount of current is passing through it. So let's first find the total current that is passing through these resistance. So the total resistance will be equals to 40 ohms. The combination is series combination. So the effective resistance is R1 plus R2. We have a total resistance. Let's find the total current. I equals to V over R. The total voltage is 8 volt and the total current resistance is 40. So for finding the total current, we will divide 8 by 40. So it will be equal to 0.2 ampere. So 0.2 ampere current is passing through this resistance and this resistance as well. So for finding the voltage, V equals to IR. So the current is 0.2 and resistance is 10. 0.2 times 10 is 2 volt. If 2 volt is the amount of reading here, so the remaining voltage 6 volt would be at 30 ohms resistance. So the correct answer is option A. Let's see question number 29. A student connects the circuit as shown, which switch must be closed for the bell and a ring, bell to ring and a lamp to light. So we have to close two switches, that is switch 2 and switch 3, so that this bell and the lamp would become in parallel combination, as well as option switch 1. So these three are the switches that needs to be closed so that these two devices could be connected in the parallel combination. So the correct answer is 1, 2, and 3. Option C is the right answer. Let's move to our next question. Question number 30. We have three fuses connected at different position, fuse X, Y, and Z. Three fuses have been connected to a toaster, but only one or two have been connected correctly. So we have to identify that which fuses are connected correctly in this metal toaster. So the fuse is always connected in series combination, and it is always connected in the live wire. So the fuse connected in series with the live wire is the fuse that is fuse X. So option B is the right answer. Let's move to our next question, that is question number 31. A metal wire of cross sectional area has a diameter D and a length L. We have a diameter D and a length L. Which pair of changes, if both are carried out, must increases the resistance of the wire? So we know that resistance is directly proportional to the length of the conductor and resistance is inversely proportional to cross-sectional area of that wire. So resistance increases means that the length of the wire should be greater and area will be smaller. So increase the L and decrease the D. Increasing length will increase the resistance while decreasing the diameter will increases the resistance. So option C we have in this question is the right answer. Now let's see question number 32. Which of the following fuses would be the most suitable for a circuit in which a 2000-watt kettle is connected to a 240-volt supply? So we have a power and we have voltage. So for fuse to select, we need to find the amount of current that that device requires. So let's find the amount of current. We know that power equals to voltage time current. Voltage is 240 and the power is 2000. So current would become 2000 divided by 240. So 2000 divided by 240 will be equals to 8.33 amperes of current that required by that circuit. It's mean a fuse of 9 ampere would be more suitable in that circuit. Let's move to our next question. We have a simple question that is the Fleming's left hand rule in which we have thumb, we have a forefinger, and we have a middle finger. This is a rule that is used to find the direction of force when a current carrying conductor is placed in a magnetic field. So, thumb represented the force, forefinger represented the magnetic field, while middle finger represent the direction of current. So, FBI is the force, field, and current. Option C is our right answer. Let's move to our next question, that is question number 35. Which of the following device is an example of electromagnetic induction? So the AC generator is a device that work on the principle of electromagnetic induction. Option D is the right answer. A magnet is suspended from a spring so that it can move freely inside a stationary coil. The coil is connected to a sensitive galvanometer. Magnet repeatedly moves slowly up and down. What does the galvanometer shows? So here we have the electromagnetic induction until till this magnet oscillate to and fro in this coil. We will get a deflection in this galvanometer, and we know that the type of induced current is the alternating current that changes the direction. So the needle of this galvanometer will move right and left. So a steady current of will move to both side of that galvanometer. So a constant current changing reading will be shown on this galvanometer. Let's come to our next question, that is question number 37. A current carrying coil is placed in an external magnetic field that induces or that experiences a turning effect. So how can this turning effect can be increased? So the correct answer is increasing the number of turns in the coil. The factors of torque are B, I, and A, where torque acting on that coil can be increased by increasing the magnetic field strength, amount of current, number of turns, and area of the coil. So these are the four factors on which the turning effect of that coil depends. Option A is the right answer. Then we have question number 38. So we have a magnet in which a wire is moved up and down that experiences an motive force. When a wire is placed, move upward between the poles of a magnet, electromotive forces induced across the end of the wire. So this device uses to induce an EMF by this process. So an AC generator is the uh, device in which this same phenomena is applied. Option B is our right answer. So let's move to our question number 39. So we have a logic circuit and we have to identify the output X and Y. So we know that this is our NOT, this is NAND, and this is NOR. So we have a zero input in NOR, so it will make 1, and we have input 1 in Q. So this input is given to this NAND as well as this NOR. Similarly, this output 0, output 1 is going to the NAND. So let's make the output of this NAND gate. NAND works such that if inputs are 1 in 1, AND would be 1 and NAND would become 0. So output here is 0. This output is the output X as well as in the NOR. So 1 0 OR of 1 and 0 is 1, and the NOR of 1 and 0 would be 0. So the output we get is at X and Y are 0 0. Option A is the right answer. So here we have the last question in this paper. Which of the following quantity will vary in a continuous manner? So these type of quantities are known as analog quantities. So option A is the right answer. So then we have Akhan University Examination Board, May-June 2021 ATP paper. So let's solve this paper and come. Let's come to our question number 1. The time period of a 85 centimeter long pendulum is. So we know that the time period of a pendulum is equals to 2 pi square root L over G. So length will become 0.85 meters. So let's solve 2 pi square root of length is 0.85 and the gravitational acceleration is 9.8. So the result is 1.85 seconds. So the correct answer is option D. Next, we have question number 2. Time period of the pendulum is independent of which of the following quantities? So the correct answer is option C, that time period is independent of mass and time period is independent of the amplitude of the vibrating body. Option C is the right answer. Let's come to our question number 3. Which of the following shows how a ray of light would pass through the glass block in air? So if you can see this here, we have air and the other medium is glass. So option B is the wrong answer because ray of light entering from air to glass is bending away from the normal. Similarly, in this case, option C is the wrong answer because a ray, incident ray that makes 90-degree is bending away from the normal. It's mean this is the incorrect answer. The correct answer is option A. The light is bending towards the normal, and when enters from glass to air boundary, leaves the glass air boundary, it bends away from the normal. Option A is the right answer of this question. Then we have question number 4. So in this question, a teacher demonstrates the dispersion of white light using a triangular glass prism, which diagram correctly shows the dispersion happens. So we know that white light consists of 7 colors, and each colors have different wavelength and different frequency. So the bending depends on the frequency. Greater the frequency, greater will be the large amount of bending will occur. So when this white light enters from air to glass, it bends, and the bending is different for different type of waves, different types of colors. Option B is the right answer for this question, in which A to glass entering of light shows the dispersion. Similarly, when it exits the glass, it is uh, further refracted. In option A is incorrect, because when light enters from A to glass, it is not splitted into different colors. Let's see question number 5. We have a simple question. Refractive index of water, it is equal to 1.33. Which label diagram is the focal length of the convex lens? So the correct answer will be option B, because incident parallel rays passing through a point, and this point is known as focus. So the distance between optical center and focal length is focus is the equal to focal length. Option B is the right answer. Let's move to our question number 7. A student carries out an experiment to investigate the resistance R. She takes a series of reading a potential difference and current and plot a graph of her result to verify Ohm's law. So, which circuit should be used? So, she uses voltmeter and ammeter with a resistor. So we know that voltmeter will be connected to in parallel to that resistor, and ammeter will be connected in series. So the correct answer is option A, in which voltmeter is connected in parallel with that resistor and ammeter is connected in series combination. Let's come to question number 8. A student uses a circuit shown to determine the resistance of two identical resistors. So these resistors are identical. The voltmeter reading is 2.2. So this is 2.2 volt. That would be the EMF of that battery. And the ammeter current reading is 0.25. What is the resistance of each resistor? So R total resistance will be equals to V over I. Total voltage is 2.2 and the total current is 0.25. So let's divide 2.2 divided by 0.25. So the total resistance is 8.8 ohms, and these are connected in series. It's mean that each resistor is of 4.4 ohms, so that in series combination the total will become 8.8. So the correct answer is option D. Then we have question number 9. The diagram shows two resistors connected in a circuit. What could be the combined resistance of these resistors? So we have a simple parallel combination. So 1 over R would be equal to 1 over 6 plus 1 over 12. So by solving this, we will get R is equals to 12 over 3, that is equal to 4 ohms. So option A is the right answer. Then we have the last question in this ATP exam paper, which diagram represents the direction of magnetic field around a straight current carrying conductor. So for this, we need to apply the right hand grip rule. Right hand grip rules states such that whenever we need to find the direction of magnetic field around a straight current carrying conductor, hold that wire with a curled finger and a thumb points the direction of current. So our curled fingers will be the direction of magnetic field. So this dot represents the current out of the page, and these lines represents the direction of magnetic field. So according to the right hand grip rule, the correct answer for this last question, that is question number 10, the correct answer is option D.